Now you guys saw what happens when a ray of light passes through multiple media, correct? Now, and also you guys learned about principle of reversibility. Here, principle of reversibility is used to figure out what is the normal shift, meaning, see, if you guys have noticed that whenever there is a bucket of water and if you actually look at that water in a different angle, you will be able to see the bottom of the bucket. Now that is basically normal shift, meaning you feel that the bottom of the bucket has risen up. That is the normal shift. Now there is a mathematical explanation as to how to find the normal shift. So let's assume that we have a bucket of water. Okay. So now remember here what we are considering is the object has to be at the bottom here. Okay. So imagining this is the bucket this is filled with water. Alright. Now the object is at the bottom of the tank. So let's say this is the object. So let's call that object as O. Now this is the source of light. So obviously the rays, the refracted ray and everything, it has to move at certain angle, correct? So this is one ray of light which is moving. Now if you look at it, this is at 90 degrees. So this goes undeviated. So whatever ray of light which moves through the normal, those rays of light will go undeviated. And we also need to have one more. So let's say another ray of light which is moving like this. So this is another ray of light. Now at this point we need to draw a normal. So we have this to be the normal. Since the ray of light is coming from denser to rarer medium, the refracted ray will be moving away from the normal. So like this. Now, so what we have is we have this to be I and this to be R, correct? So let's name it. So this is one of the rays which is moving undeviated, and this is one more ray which is moving. Now let's call this point as A, let's call this point as B, this is C, let's say this is N dash. Now what we have here is OA is the actual depth of the object, correct? Now what we are trying to find out is the normal shift. Now to find the normal shift, first we need to know what is the refractive index of the medium. Now here we are taking water, it could be any other material also, right? For that what we do is, so we retrace the path back here. So if BC is the refracted ray, then if we trace the path back, it will come to this particular point here, right? So let's name that point as I. Now why this I is important, you guys will know just now. See, if this is I, then even this angle will also be I, because they are alternate angles. And if NBC is R, then even AIB, even this angle will also be R, because they are corresponding angles. So what we have is, we have OBN dash angle is equal to BOI angle is equal to I, the incident angle, and we have NBC is equal to AIB is equal to R, right? Now see, if let's say this is medium B and this is medium A. Now by Snell's law we have mu is equal to sine I divided by sine R, correct? This is the case where the light ray is moving from rarer medium to denser medium, but here it's the opposite. The light ray is moving from denser to rarer medium. So we'll have mu is equal to sine R by sine I, correct? So sine r by sine I. So we need to know what is sine r, we need to know what is sine I. This is the reason why we extend it. So we get this I point, and here we use the triangle, then we get to know what is sine r. Okay, now to find sine r, so we'll take triangle AIB. Now in triangle AIB, if you take sine r, so sine r will be AB divided by IB, right? Then in triangle OAB, if you take sine I, so sine I will be AB divided by OB, right? So now what we do is, this is an important part, we try to calculate what is the refractive index. So sine r, so we have mu is equal to sine r, which is AB divided by IB over AB divided by OB. Now AB cancels, so we have mu is equal to OB divided by IB. Now if you look at the figure, A and B, they are very close to each other. So in place of OB, we can write OA, and in place of IB, we can write IA. So we have mu is equal to OA divided by IA. So we have OA divided by IA. Now this is nothing but the real depth by apparent depth, correct? So we have mu is equal to, so real depth divided by apparent depth. This gives the refractive index of the material. So once we have the refractive index, we are trying to find the normal shift, correct? Now normal shift is what? OI is the normal shift. So this is the normal shift. That's nothing but OA minus AI, right? So what we have is, let's say D is the normal shift. So D is equal to OA minus AI. Now D is equal to OA, we'll take it outside as common. So we'll have 1 minus AI divided by OA, right? See, OA by AI is mu. So this will become 1 by mu. So we have D is equal to OA into 1 minus 1 divided by mu. Now OA is the real depth, right? So let's call this as some, let's say, value T. So we have D is equal to T into 1 minus 1 by mu. So what we have here is one very important thing. We are talking about the refractive index, so which is a relative refractive index. So we have to write it as D is equal to T into 1 minus 1 by A mu B. So this becomes the normal shift. So first we found out what is the refractive index. Using that, we find out what is the normal shift.